You walk into a store or open a browser, and immediately you're hit with a wall of data. Gigahertz, terabytes, DDR5. It is a sea of acronyms and numbers that feel like they require a computer science degree to decode. But nobody actually goes shopping for a pile of gigabytes. What we are really looking for is an outcome. We want our applications to snap open instantly, our videos to play without stuttering, and our work to feel seamless. This image highlights the problem perfectly. Looking at a computer as a crossed-out list of technical specifications gets us nowhere. We have to flip the switch. We need to view these devices as engines dialed in for human experience. To make sense of it all, we have to become translators. If we take every piece of technical jargon and map it to a physical, real-world function, the mystery disappears. Once we stop treating a laptop like a complex math equation, we can start to see it for what it actually is, a highly organized physical workspace. Imagine shrinking down and stepping inside the casing of your computer. You wouldn't find a mess of silicon. You'd find a bustling, organized physical office where different workers handle distinct tasks. Right in the center is the processor, or CPU. Think of this chip as the logic brain, the head boss of the office making every critical calculation and directing traffic. In this schematic, notice the brain and the working table. RAM is the physical desk for active projects. As the bottom text explains, a bigger working table means opening many apps without slowing down, avoiding the constant paper shuffling we experience as lag. Upgrading your core specs doesn't require a deep dive into voltage. It simply means hiring a faster boss and buying them a much wider desk so your daily workflow never hits a bottleneck. But the boss can't leave every document on the desk overnight. They need long-term storage, an archive cupboard. For years, we relied on hard disk drives, which physically spun around to find files. Today, we use solid-state drives, or SSDs. This visual breakdown shows why that shift matters. Up top, the old HDD is a rusty car. Booting up your machine means a long, sluggish wait. Down below, the modern SSD is a bullet train. It guarantees instant startups and frictionless loading. So the boss has a fast desk and a high-speed archive. But what happens when the office needs to render a 3D model, edit a 4K video, or run a high-end game? The logic boss is not an artist. As you can see in this architectural comparison, an integrated graphics chip handles standard office work and streaming just fine. But for heavy visual tasks, you need the right side of the graphic, a dedicated GPU. This is a completely separate chip, essentially a specialized artist hired strictly for heavy visual lifting. Warning tone. If you hand a massive video editing project to the standard logic boss, the entire office grinds to a halt. Matching the right internal worker to your specific daily tasks is the only way to keep the system running. For decades, those two workers, the logic boss and the visual artist, handled everything. But computing is moving past manual execution and stepping into automated intelligence. We are now introducing a third, entirely new worker to the office. This is the Neural Processing Unit, or NPU. Think of it as a dedicated AI brain. In this diagram, you see exactly how the AI brain operates. Instead of forcing the standard CPU to sweat through heavy workloads, the NPU intercepts those golden AI tasks directly. This division of labor keeps performance smooth while actively preserving your battery's fuel tank. Looking at this AI workflow, we see the practical results. The AI core branches out to automatically handle background blur on video calls, active noise cancellation, and complex photo edits in real time. Because the machine handles all of those repetitive adjustments in the background, you are left completely free to focus on your creative work. It acts as a proactive partner, anticipating your needs rather than just waiting for commands. Evaluating a machine requires looking beyond today's workload and accounting for the software demands of the next several years. Down at the bottom of this graphic is a speedometer labeled TOPS, which stands for trillions of operations per second. This is your horsepower metric. It proves exactly how strong and capable the machine's AI systems are. This matrix lays out the stakes. A legacy PC drains its battery normally and offers limited future capability. But an AI PC provides lightning speed, optimized battery life, and most importantly, it sits firmly in the Built for Tomorrow category. It avoids early obsolescence. If you refer to this checklist, the strategy for navigating tech is clear. Never blindly push technical specifications. Always ask what the specific requirement is, rely on relatable analogies, and you will build genuine trust. Mastering the digital workspace replaces a focus on raw numbers with a commitment to an intelligent architecture built to power your future.